Alright, this is APAB Calc, and we are continuing with 2.6, which is related rates. This is video 3 in this section. Cool, so we're going to jump right into example 4, which I categorize as like a rope problem. You'll see ones with ropes and pulleys and stuff like that. Alright, so example 4. A boat is being pulled to shore by a rope attached to a windlass on top of a pier. I'm going to preface this with the fact that I have no idea what a windlass is. I figured it out by context clues. Sometimes you'll find in problems like this that there's language that, unless you're someone who spent your spare time yachting, which I am not, or sailing, which I am not, you're going to find that sometimes there's language that makes these sorts of questions more difficult. Take a deep breath, try to ignore that, and just picture that it really doesn't matter. It could be a thingamajig, who's-y, what's-it. Try to picture the description as best as you can. So, the height of the windlass above the water is 6 meters, and the rope is being wound at a rate of 4 meters per minute. How fast is the boat approaching the shore when it is 12 meters away? Okay, cool. So, let's do our best to draw this, even if we don't know what a windlass is. Alright, so here's what I've got. A boat is being pulled to shore by a rope attached to a windlass on top of a pier. The height of the windlass above the water is 6 meters. Okay, so here's what we've got. We've got water, right? Assume it's horizontal despite my inability to draw. I've got a boat. Cool. I'm just going to make it a sailboat because boat. All right, cool. Okay, so what we know is it's being drawn into a pier, and the thing that's pulling it in, the thing that the rope is attached to, is apparently 6 meters above the water. So, like, I don't know, whatever, that's a pier. But the thing the boat is being wound by, which is apparently called a windlass, or the rope is being wound by, which is apparently called a windlass, is 6 meters above the ground. And then there's a rope attached to the boat that we're going to assume is at water level. I recognize that in reality it probably wouldn't be at water level, it'd probably be up here, but we're just going to assume that it's attached at water level. Okay, so here's what we've got. We can assume water makes a 90-degree angle with whatever is standing vertically. In this case, apparently it's a windlass. I'm going to call this R for rope. So this is the rope, right? And the rope is being wound, right? So the rope is getting shorter because it's being wound around this thing, right? And we know that that rope is being wound at a rate of 4 meters per minute. So dr dt is a negative 4 meters per minute. And the reason I wrote negative 4 is because the rope is getting shorter as the boat is pulled into shore, right? And the question is, how fast is the boat approaching the shore, right? So that's going to be this distance here, right? So I'm going to call that B for boat, okay? So the question is, what we want to find, because the boat's moving this way, right? We want to find dB dt at the moment when B is 12 meters, right? That's what we want out of this, okay? So there's my diagram and my rates, okay? And again, I don't, my boat doesn't look like a real boat, and I have no idea if my diagram is like actually sensibly what this would look like in a real world. That's fine. Context clues tell me that this is the setup they're describing. Cool. So, once I have that set up, right, I'm going to go ahead and write my equation, which yet again, shockingly, is Pythagorean Theorem. So, b squared plus 6 squared equals r squared, right? So, when I go ahead and differentiate with respect to time, I'm going to get 2b dB dt plus 0, because I'm differentiating a 36, which is 0, equals 2r dr dt. Right? Now, the thing I want is dB dt, so if you want, you can go ahead and solve for that right now by dividing by the 2b. That's fine. You also don't have to if you don't want to. Right? So dB dt equals 2r dr dt over that 2b, so I'd probably cancel the 2's. Okay. When I go to plug in and substitute my specific stuff, well, now we're talking at a specific moment. We're talking at a moment when this is 6, because it's a constant, when this is 12, and we don't know r. Right? So we are going to need r. If you look at this, there's an r in the formula. So we're going to have to use Pythagorean Theorem. This is not a convenient Pythagorean triple. Not a convenient Pythagorean triple. So I'm going to get that r squared is the square root of 6 squared, which is 36, plus 12 squared, which is 144. Right? So I get that my r is the square. Sorry, don't need an r squared there. R is the square root of $1.80. Right? If you definitely has a 9 in it, also has a 20, therefore it's 9 and 4. Right, so you can take out a 36 and have a 5. So this is a 6 root 5, right? Because this is a 36 times a 5. All right. So I get a 6 root 5. So now if I go back into substitute and I want to answer my question, I'm going to get that my dB dt is r, which was 6 root 5, over b, which was 12, times dr dt, which was negative 4, right? So it seems to me like I get a negative 24 root 5 on the top and a 12 on the bottom, so I think I get negative 2 root 5 meters per minute. And then I want to read the question, right? So this is still substituting. Then I need to answer the question, right? So the answering the question is going to be where you actually have to pay attention to see if any of the wording. So remember, if you get a negative answer on related rates, you want to see if the wording is such that you don't want to include the negative. It says, how fast is the boat approaching the shore? So my answer is 2 root 5 meters per minute. I don't need the negative, and the reason I don't need the negative is covered by the fact that since the boat is approaching the shore, B is getting shorter. It's already saying how fast is it approaching the shore. It's approaching the shore at a positive rate of 2 root 5, right? How fast is basically asking you for the scalar, and then the phrase approaching the shore is telling you why there's negative. So my answer would be 2 root 5 meters per minute. And again, it's meters per minute because B was measured in meters. It was a length here, which we've been using meters, and T is measured in time, which in this problem was minutes. Okay? Cool. So I'm going to erase my E4, and then I'll read you P4, and you can give P4 a try on your own before we do it. All right. And I'm not sure. It really depends on the person whether you can read these problems without me reading them to you. I'm not sure how good the video does at showing the problem in terms of everybody's individual eyesight. All right. So P4. All right. A man on a pier pulls a rope attached to a small boat at a rate of 1 foot per second. If his hands are 10 feet above the place where the rope is attached, how fast is the boat approaching the pier when there are 20 feet of rope out? Okay, so again, pause me if you don't want to do this with me. I'm going to have the guy be on the pier in the other direction, just to show that it doesn't matter which direction he's standing. And this is my really fancy version of the guy on the pier. Okay, so wherever the rope is attached to the boat, this height is 10 feet, right? His hands with his rope are 10 feet above wherever the rope is attached. I'm going to use R again for rope. I'll use B again for boat. Okay. So here's what we know. We know that he pulls the rope at a rate, so the dr dt, right? He pulls the rope at a rate of 1 foot per second. Because the rope is getting shorter as he pulls it, I mean, the rope physically isn't getting shorter, but the distance between the man's hands and the boat is getting shorter. That's going to be a negative 1 foot per second, right? And we know the 10 feet's there. How fast is the boat approaching? So the thing we want is what is dB dt, right? When R is 20. So in this case, it's not going to be the B that has a given value, it's going to be R that has a given value. So again, I'm going to go ahead and make my equation, right? So that was my diagram and my rates. I'm going to make my equation, which is going to be that B squared plus 10 squared equals R squared, right? When I differentiate, I get 2B dB dt plus 0 equals 2R dr dt. And again, now in this case, I want dB dt again, so if you want, you don't have to, but if you want to solve for this, you can divide the 2B over, and you're going to end up with the exact same equation we got in the last one, literally exactly the same because I picked the same letters. You don't have to pick the same letters I picked, but and the 2's would cancel, so this is what I've got. So now when I go to substitute, I need to look at this exact triangle at this moment. Well, at this moment, this is a 20, and this is a 10, and I don't know what B is. So I need to find B. It is not a convenient Pythagorean triple, so since it's not a Pythagorean triple, it looks like I'm going to have to go ahead and do Pythagorean theorem. So I'm going to get, because this is the hypotenuse, right, my B squared is going to be 20 squared minus 10 squared, right? So my B is going to be the square root of 400 minus 100 is 300, right? That's a 10 root 3, because you can take a 100 out. And again, you don't have to simplify, but I think it's going to be, it's helpful if you have that skill. If you left it as a root 300, it's not the worst thing in the world. So when I go to substitute in, that means that my dB dt is going to be R, which was 20, times dr dt, which was negative 1, over a 10 root 3, right? So if I clean that up a little bit, I get that my dB dt is a negative 2 over root 3. Now, that answer's fine if you want. It's in feet per second because my B is measured in feet, right, and my time is seconds. Some of you are going to want to rationalize that because you've spent the entirety of your math careers, or at least since pre-calc, being forced to rationalize things. And that's not wrong, you can, but I will say that in calc, you don't necessarily have to rationalize it. So when I answer the question, right, so my answer to this question, because it says how fast is the boat approaching the pier, that's asking for a speed. So my answer is negative 2 over root 3 feet per second. Or if you stubbornly felt the need to rationalize by multiplying by root 3 over root 3, you could write this as a negative 2 root 3 over 3 feet per second. But what sorry, ignore the negative. I take it back because I just want the speed. So I would say that this is the better answer, right? Because you're not risking making a silly mistake. Now, it is funny that I made the silly mistake of writing a negative in the actual literal moment where I was telling you that it shouldn't be negative. But this answer is also fine. The rationalized answer is also fine. Notice I don't have the negative because the word approaching, how fast is it approaching, is asking you the speed at which it's approaching. We already know that the negative sign was because the thing I assigned as b is getting shorter. But I'm the one who assigned b to solve the problem, right? They didn't ask me what is db dt. I'm the one who assigned b. I'm the one who understood that db dt would give me the answer they were requesting. All right, cool. Let's go ahead and do our E5 P5. On to the next paper. Okay. E5 P5. All right. E5 P5 are going to be about shadows. So in E5, a man 6 feet tall walks at a rate of 5 feet per second toward a streetlight that is 16 feet above the ground. At what rate is the tip of his shadow moving? At what rate is the length of his shadow changing when he is 10 feet from the base of the light? Okay, so there are two questions to this one, so we're going to have to pay a lot of attention here. So let's go ahead and draw our diagram first. So in E5, so I have a lamppost that is, or a street light that is 16 feet above the ground. So that's a set 16 feet. This lamppost does not get taller or shorter during the problem, right? I also have a 6-foot dude that is not getting taller or shorter during the problem. So somewhere over here, there's a guy. I did not do a good job of making him proportional. I guess that's close-ish to 6 feet. Okay, so there's a dude. He's 6 feet tall. I can also label that because it is also a constant. The guy is not getting taller or shorter during the problem. Okay, so the way shadows work is that a light shines down, it hits the top of your head, and that's the tip of your shadow, okay? So in this diagram, what's happening, we can assume the street light makes a 90-degree angle with the ground and also the dude, okay? So what's happening here is that this length right here is his shadow. Now, I don't love using S because my S's look like 5s, but I'm going to call it S for shadow. So that's just this length is the length of his shadow, right? But this length, right, this entire thing that I'm going to call X, right, this entire thing, I don't think I'm going to call that X. I lied. I'm going to call this thing P for his distance to the pole, okay? Now, there's a separate argument that you might want to make this whole thing some variable because this is the length to the tip of his shadow. Right here is the tip of his shadow, okay? So this is a tricky question. So I have how fast he's moving and also how fast the tip of his shadow is moving, okay? So the trick is, if you want to talk about the tip of his shadow moving, you're actually talking about this entire length. So if you want, you could arguably make a third variable, right, that refers to the tip of the shadow. I was going to use capital T, but that's a little bit iffy because there's already a T that we use for time. So I'm just going to use X, right, for the entire length here, meaning that for the record, X is P plus S. It's how far the guy is from the pole, and it's also, and how long his shadow is. It's the sum of P and S, okay? Cool. So, at what rate is the tip of his shadow moving? Okay, so let's call that question A, right? Let's say that there are two questions here, because there are, right? So I'm going to call at what rate is the tip of his shadow moving? I'm going to call that question A. And the second question, at what rate is the length of his shadow changing when he's 10 feet from the base? We're going to call that B. So we actually have two problems here. We should do one at a time. Okay, so I need this X, this tip of the shadow. I need this for part, yeah, we're going to say that I need that for my first part. So the trick here is that this is not Pythagorean theorem. So what I want you to notice here is we know nothing about the hypotenuse. Nothing, right? We know nothing about the hypotenuse, and it's not going to make our lives better to assign a bunch of extra variables. But what we do have here are triangles that are proportional. Because we have this big triangle that has an x and a 16 and has to have the same angle right here. And we have this little triangle that has an s and a 6. Okay? So I know that these have to be similar triangles, right? They're not congruent. They're not the same triangle. This is a smaller version of this triangle. Meaning that the equation I want to set up is that x is 216 as s is 26. So when I differentiate, I'm going to have, so if it helps you see it a little better, you can make this a 1/16 in front of the x equals a 1/6 in front of the s, right? So when I differentiate, I'm going to get 1/16 dx dt equals 1/6 ds dt. Right? Oh, well, that's tricky. That's tricky. Hang on, we're going to redo this in a sec. Let's pause. So I was going to, I debated, like, deleting the fact that I pointed out that was tricky, and then I decided that's dumb, because the same thing that happened just now sometimes happens in front of a class when I'm teaching you guys, and it's important for you to see that sometimes people fumble, right? Like sometimes people maybe go off in a wrong direction. So here's the tricky part of this problem. There's a stupid trick. It's easier to do the second part first, sort of. It's either that it's easier to, so it's easier to find ds than it is to find, so the problem is that we don't know anything about x, right? So let me go back up for a second and show what we know. And I did forget to label one thing on here, and that's a factor. The guy is walking towards the lamppost, or towards the street light, so dp dt is negative 5 feet per second. So negative 5 feet per second. And I did forget to label that on there, so my bad. And that's part of the reason that this happened. So the problem is that we just don't know dx dt. And that's problematic, right? Because I have this fairly simple thing to differentiate. It also makes it really clear why they didn't give me a time, because if you notice, none of this is time specific. But the problem is that in part A, right? So in part A, we want dx dt, right? And they don't give us a time, so they're saying at any time. Like there's no specific stuff. And in part B, the thing that they seem to want is ds dt, right? The length of the shadow would be ds dt, right? So here's the problem. We don't know ds dt, right? So this is the thing, dx dt is the thing that we want in part A, but ds dt is a thing that we don't know. So what makes this tricky is that this is the question they ask us about in part B. So what makes this tricky is you just don't know enough to find ds dt yet, right? So in order to answer this question, we actually need to use what we call an auxiliary equation. So an auxiliary equation is a different equation that might help us essentially relate quantities we actually know, like dp dt, to quantities that we have. So in this case, my auxiliary equation is this one that I wrote down here, was that if I'm going to call that s, right, if I'm going to call that s and that p, that x is p plus s, right? So if I want, I can differentiate my auxiliary equation, right, and essentially get dx dt is dp dt plus ds dt. Now, what's weird about this is that when you plug this in for dx dt, you're going to say, wait a second, that doesn't actually make anything better, because the thing I wanted to find is dx dt, right? So there's a couple ways you can deal with this. You could either plug this in exactly as it is for dx dt, which is fine, but if you do that, you're actually going to find ds dt first, which was part B. Or you can solve this for ds dt and say, wait a second, instead of doing that, what if I solve and realize that ds dt is the same as the thing I want, dx dt, minus the thing I know, which is dp dt. What that's going to do is it's going to give me an expression that looks like this. 1/16 dx dt equals 1/6 dx dt minus 1/6 dp dt. Well, I know dp dt, and I want dx dt, so this is going to be enough for me to be able to figure out this problem. So it's up to you. I'm not a huge fan of having all of these fractions. Sorry, didn't realize it wasn't far enough over. I'm not a huge fan of having all these fractions. One way you can get rid of all these fractions is by multiplying by the least common multiple of 6 and 16, right? So that's one option, which would be 48, right? If you multiplied by 48, right, 48 has both 16 and 6 as a factor, and what you'd end up getting is you'd end up getting 3 dx dt equals 8 dx dt minus 8 times this thing that we know to be negative 5, right? So I would end up getting negative 5 dx dt equals a positive 40. So dx dt is a negative 8 feet per second. So that's how fast the tip of his shadow is moving. So the answer to part A is the tip of the shadow is moving at 8 feet per second, okay? And then the answer to B is actually solvable by knowing that this auxiliary equation. So the funny thing about doing this is you've inadvertently done all of the work. Sorry, it fell asleep. You've inadvertently done all of the work for B already because we know ds dt, which is the thing I want, is equal to dx dt, which we've established is, so dx dt was a negative 8 feet per second, right? Minus dp dt, so that would be plus a 5 feet per second. So I end up getting that ds dt is a negative 3 feet per second. So when they ask at what rate is the length of his shadow changing, now the answer here for B is going to be negative 3 feet per second, because note the difference. Sorry, at what rate is the tip of the shadow moving? It should also be negative 8, sorry. So negative 8 feet per second and negative 3 feet per second, because neither of those questions had a direction included, right? They asked the rate at which something is moving. So, cool. All right. Let me see how I feel about that. At what rate is the length of his shadow changing? So the length of the shadow is getting shorter. Right. And the tip of the shadow, yeah, I stand by it. So I stand by, so the shadow itself is physically getting shorter, so that's the rate of change of the shadow. The rate at which the shadow is moving, I would argue the rate at which the shadow is moving could arguably be considered as positive, because we don't care which direction it's moving. I would argue this could possibly be construed as positive. I'll be honest, every once in a while that happens, and you're like, I'm unclear about it. So you could, if you felt uncomfortable, you could write this answer and then say, so at a speed of 8 feet per second, if you really wanted to cover your bases if you were uncomfortable. I will say that this one is definitively negative because the shadow is getting shorter, and they ask the rate of change of the length of the shadow. Okay, so anyway, that's E5, fairly long explanation about it. Let's do P5. So I'm going to erase this. Now, P5 is the same situation. You're going to be asked 2 questions. You may find that it's easier to do part of the second question first, or you might find that you sort of inadvertently answer both of them with the same work. So let's read P5. A lamppost is 20 meters high. A man of height 2 meters passes under the lamppost and continues walking at 3 meters per second. At what rate is the length of his shadow increasing? It should say how fast, not how fast. How fast is the tip of the shadow moving? Now, how fast is a speed question, so that's definitely, so how fast is definitely going to be a positive. So let's look at, so A, right? So A, at what the length of the shadow is increasing, we'll call that A, right? Now, because the shadow is increasing, it's definitely going to be a positive answer, right? But then for B, they also ask how fast is the shadow moving, right? So how fast, and that should say fast, not fat, fast is speed, and that means that it's definitely going to be a positive answer. So we're looking at 2 positive answers here. So an important thing here is that the man is walking away from the lamppost because he passes under it, right? He goes under the lamppost and keeps walking. So, so here's my lamppost, right? It's 20 meters high, right? And the guy is 2 meters high. Okay. All right. So I'm going to use S for his shadow again, right? I'm going to use P for the distance to the post, and then if you want, we can use X again, or you can use something else. It's up to you. Again, this boils down to similar triangles, right? So here's what we know. The guy is walking, so this, right, so dp dt, the distance between the post and the guy, is a positive 3 meters per second, right? So that's what we know. So I essentially have two equations, right? I have my proportional triangles equation, which says that this triangle with the s and the 2, and this triangle with the x and the 20. Oh, also, if you really don't like the x thing, if the x thing makes you feel uncomfortable, you could also do this triangle and just call it s plus p, right? And you could know that when you hear tip of the shadow, right, that when you hear tip of the shadow, it means s plus p, right? The tip of the shadow is s plus p. So if you're really distracted by this extra variable, if you're like, you know what, Hogan, I'm just not about that, that's totally fine. You don't actually have to have that extra variable, right? That's one way to deal with this if you're just like totally over it. The trick is, again, the length of the shadow, though, would just be s, right? So if you chose to do it this way, if you wanted to skip out on this proportion, you don't have to have the auxiliary equation if you use these two, right? It's the same concept as using these, it's just without the auxiliary equation. So if you did it this way, you could say s is to 2 as s plus p is to 20, right? And I didn't actually mention this before, but this is a great time to just get rid of the stupid fractions. I didn't do that before. It probably would have been smarter to do that before, but I didn't do it in E5, and sometimes when you look back, you're like, well, that was stupid. I should have done that in E5. Here, the smart thing to do is multiply the 20 over. If you multiply the 20 over, you're going to get a 10s equals s plus p. You get 9s equals p. Well, now I have a much easier problem, right? So I actually made example 5 inadvertently a lot harder, and you're going to find that sometimes you do that, and then you're kicking yourself. And again, I could go back and edit the video so that didn't happen, but that seems stupid. Right? It's important to see that sometimes you're not going to do things in the best way possible, and that's just part of the math, right? So 9 ds dt equals dp dt. Well, I know dp dt because that's how fast the dude's walking. So essentially I can divide the 9 over now if I want, because so a quick heads up, right? At what rate is the length of the shadow increasing? Well, s is going to be a is going to be ds dt, and b is going to be the derivative with respect to time of s plus p, right? Which we called x before, but like s plus p. So essentially it's going to be ds plus dp. So when I go to substitute my specific stuff, right, I get that ds dt is 3 divided by 9, or 1/3 meters per second, right? So that's so this is my answer to the first one. This is A. That's how fast the tip of the shadow, or the length of the shadow is changing. Then for my second question, right, for B, essentially I want dx dt, which is really just ds dt plus dp dt, right? So that's going to be 1/3 plus 3, right, which is 1/3 plus 9/3, or 10/3 meters per second. Okay, so that's my answer to the second question. That's how fast the tip of the shadow is moving, right? So again, one thing to take away from this is that my example 5 was a bit more of a hot mess, and P5 went a lot better. That's going to happen to you. I've been doing related rates problems for 23 years, right, minimum, and sometimes you're just not going to see it, and you're going to do something in not the most effective way. Don't beat yourself up, and then when you see there's a better way to do it the better way, but it's going to happen. So better if you see me occasionally do that too. It's good for all of us. All right.